So 5.3 is equations of lines. We're talking about lines of the equations of the tangent lines and of the normal line. So that's what you guys are going to learn how to do today. So we're going to start off with the tangent line. We've been working with that a lot because that is when we find the derivative, we basically are finding a general rule to find the slope or the gradient of the tangent line. Remember, the tangent line is that line that intersects the curve at exactly one point, okay? And in this picture, we can see that that's point A, and it has the coordinates A, f of A, because that's what y is f of that x, right? What you see also on that opening flap of the foldable is you see this equation. This is the equation to write the tangent line, the equation of the tangent line. F prime of A. Remember, anytime you see F prime, that indicates what? The derivative. And remember, the derivative is the gradient of the tangent line. So essentially, this right here, F prime of A, is the slope at that particular point. Then we'll have x minus A, and all A represents is the x coordinate of the point where it's touching. And then minus F of A is the y coordinate. So if anything, it's kind of like a rewriting of point gradient form. You guys remember point gradient form was y minus y1 equals m x minus x1. It's the same thing, except this time all they've done is move over the that y value. And actually, I think this is supposed to be a plus, so please make sure you make that change. It's supposed to be a plus. Because as you can see here from point gradient form, I wrote it down wrong on the slide and on the foldable. You pretty much are just moving over that y coordinate point, and then you can simplify from there, of course. Okay? So let's just jump right into it. Example 1, it says find the equation of the tangent to f of x equals x squared plus 1 at the point where x equals 1. Okay? Well, first off, in order to write any line, any equation of a line, we always need a point, correct? And right now, all we have is the x coordinate of that point. How do I find the y coordinate? What? You plug it into the equation. So we're going to plug 1 into our function. We're doing that so then we can get the y coordinates for the point. So 1 squared plus 1 is 2. So our point is 1, 2. Now the last thing that we need to write our equation is we need our slope. And we find the slope for this particular tangent line by doing what? Or by finding what? We need to find the derivative. So we need to find the derivative of the function, and then after we do that, we need to actually plug in the x value to get the actual gradient. So first, what's the derivative of x squared plus 1? And then we'll plug 1 in to actually get the gradient. This is equal to the gradient of the tangent line. So now that I have my gradient, and now that I have my point, I can write the equation of my tangent line. It is y equals f prime of A, which we already know is 2, times x minus A, which is the x coordinate of the point, which is 1, plus f of A, which is the y coordinate of the point, which is 2. Of course, we want to distribute this and simplify. So the equation of our tangent line is y equals 2x. Yes. Correct. But there are a lot of 2's, but this particular 2 is the slope of the tangent line. Okay? And just for that visual, this is the graph of x squared plus 1. It's a quadratic. And so what we just found by having y equals 2x is we just found the equation for the tangent line at the point 1, 2. We found that right there. That's what we found.
Miss Anderson?
Yes.
Where did you find x minus 1 plus 2?
This part right here was using the formula that's on the front side of the foldable on the last slide, which was y equals f prime of a, which represents the slope, x minus a, which is the a is the x coordinate of the point, plus f of a, which is the y coordinate of the point. And we got 1 from the original problem, and we found the 2 by plugging in the 1 to the original to get the corresponding y value.
Okay, I get it.
Okay. Questions? Let's look at the next one. It says, consider the curve y equals x to the third minus 4x squared minus 6x plus 8. We are trying to find the equation of the tangent line to this curve at the point where x is equal to 0. So again, we're finding the equation of the tangent line. We're given the x coordinate of the point where we're trying to find the where the gradient's touching, but we don't have the y coordinate. How do I find the y coordinate?
Plug in 0.
Into the original equation. So I need to actually plug in 0 in for x. And as we can see very easily, the y coordinate is going to be what? 8. So the point is 0, 8. It happens to be the y-intercept. Okay? Now the only thing we need now is the gradient. So in order to find the gradient, we need to find what? The derivative. So I'm going to use dy dx because it gave it to me, the equation as y. What is the derivative of x to the third?
3x squared.
What's the derivative of negative 4x squared?
Minus 8x.
And the derivative of minus 6x?
Minus 6.
Very good. So now that I have the derivative to find my gradient, what should I do? Plug in 0. Because we are looking for the gradient at the point x equals, the gradient of the tangent line at the point when x is 0. So that means we need to plug in 0 into our gradient. That's 3 times 0 squared, minus 8 times 0, minus 6. And we find out that our gradient of our tangent line is going to equal negative 6. So the equation of my tangent line to this curve at the point when x equals 0 is y equals negative 6. Technically, it would be x minus 0, which is just x. Then plus my y coordinate of my point, which is 8. Questions on part A?
Wait, so why the thing you wrote in red is the answer to A?
Correct. I just didn't have any space and I didn't want to come over here because I'm about to use this other side for B.
Is that mx plus b? No, mx plus c.
Yes. That is gradient intercept form. Now for part B, it says, at what point does this tangent line meet the curve again? So at what point does this tangent line meet the curve again? If it's meeting, visually, what does that mean? It's where it's intersecting. So it's asking you, at what point does the tangent line intersect the curve again? We already know it's touching at 0 because that's where it's tangent, but that means there's another point where this equation of y equals negative 6x plus 8 is intersecting this cubic function, okay? So for B, algebraically, what we want to do is we want to find out where negative 6x plus 8 is going to be equal to this cubic. Visually, what that means is that on this cubic function, so that represents the x to the third equation, our tangent line is hitting at some other point. Our job is to figure out that other point. So what do I need to do to find this? Go into my calculator. All right, so in Y1, I'm going to type in that equation that represents the tangent line, and then I'm going to type in the original function. Double check, looks good. And I do want to go to a standard window for the moment, so that way I can see if I need to adjust my window. So I'm not quite sure what happened to my calculator beforehand. So zoom 6 takes me back to that standard -10 to 10 window. There is that tangent line. And there is my cubic. So here, there's that point where it's tangent to the curve at 0. It's going to intersect again outside of the window that I have, so I do need to adjust. What part of my window should I adjust? Y, which one? The Y min, because it goes down lower. So let me change this to -20. Let me see if that does it. I'm changing my Y min to -20 because I'm trying to see that intersection between this blue line and this red curve. Remember, the blue line represents the tangent and the red curve represents the original equation. Just big enough, I need that intersection point. So my graph is not spot on, but essentially that's what you were looking for. So I go second trace, option 5. And because there's 2 intersection points, I don't want the one where my cursor shows up at right now. I have to move it closer to the other intersection point. Otherwise, the graph is going to give me the intersection that I already know, which was 0. So now that I'm closer, enter 3 times. Did you guys get this?
Yes.
So then the point where the tangent meets the curve again, the point is actually the x and the y together. Not just the x, but the x and the y together. So our answer for part B is 4, -16. What y'all thinking? That's a 1.6, so 4, -16. So that's how we find the equation of the tangent line. Now let's talk about the normal line, okay? The normal line and its respective equation is what you see here. Let's make that change. That should be a plus there, not a minus. Should be a plus there. And here's the visual for it as well. You can't see the colors on your paper because it's black and white, but hopefully you can see them up here. The green line is the tangent line. The blue line is the normal line. And there's a small, tiny symbol right here. What does that symbol mean? That little, it's a 90-degree angle. The normal line is perpendicular to the tangent line. And remember, slopes of perpendicular lines are what? The reciprocal and the opposite. It's the opposite reciprocal. That's why the equation for the normal line has this as its gradient, because I have to flip the gradient of my tangent line, and I need to change the sign, okay? So normal lines are perpendicular to the tangent at the point of contact. A normal line, or sometimes it's called the normal, but a normal to the curve is the line that's perpendicular to the tangent line at that point. And because it's perpendicular, the gradient of the normal to the curve at that particular point is -1 over f prime of a. Remember, f prime of a is how you find the gradient of the tangent line. So you do the opposite reciprocal to find the perpendicular gradient, which is the gradient of the normal. So in example 3, we're going to find the equation of the normal to the curve x squared minus 4x plus 3 at the point where x is equal to 4, okay? So in order to do this, we need the gradient of our normal line. Now, I cannot go directly there. I cannot go directly to the gradient of the normal line. I have to find the tangent and then do the opposite reciprocal. Okay? So let's find my derivative. What's the derivative of x squared minus 4x plus 3? Now let's find the gradient of my tangent line. When you plug in that x value into the derivative, you are finding the gradient of the tangent line. What's the gradient of the tangent line?
4.
It's 4. So if I'm looking for the gradient of my normal line, which is what I need because I'm trying to write the equation of the normal line, I have to do the opposite reciprocal. So then what is the gradient of the normal line? -1/4. There is no way to go straight to the gradient of the normal. You'll have to find the tangent in order to find the normal, okay? So far I have y equals the gradient of my normal line, which is -1/4, x minus a, which is the x coordinate of the point, which is 4, plus y. Oh, I don't have y. How do I find it? I need to plug the 4 into the original. By plugging in an x value into the original function, you are finding the corresponding y value at that point. So it's 4 squared is 16. 4 times 4 is 16. Plus 3. The y coordinate is 3. So then over here, I'm going to have a plus 3. I am going to distribute. What's -1/4 times -4? I know, I just want to see you guys. 1. So then you combine your like terms. And there is the equation of your normal line. Right. So it says find the point where the normal to y equals x squared minus 3 at the point 1, -2 meets the curve again. Okay? So in order to figure that out, I need to find what? What do I need to find?
I have a question.
Question.
So if we're trying to find the normal equation, what is that? What does it represent?
Tangent.
I need the derivative so that I can find the tangent, and then once I know the tangent, once I find my derivative, I can find the slope of my tangent line, which means I can then do what with it? Do the opposite reciprocal to find what? Not the normal equation, but the
normal tangent. I mean, a normal gradient.
The normal gradient, then I can write the equation. So let's do that. I need to find my derivative. First, do you notice we can't do much without the original function and the derivative? What's the derivative of x squared minus 3?
2x.
Very good. Now I need to actually plug in the x value, which is into the derivative. That 2 represents the gradient of the tangent. But because I'm looking for the normal, what's going to be the slope? Or is going to be negative 1/2 the gradient of my tangent line. Do I have the full point? Do I need to find anything, any y values? No, because they gave me the full point. So I can just plug in. That's going to be a negative 1/2 x minus 1 plus a negative 2, which just turns into a minus 2. I'll distribute that over and combine my like terms. So that's y equals negative 1/2 x. What's 1/2 minus 2?
1.5.
And what's that as an improper fraction?
That's negative 3/2.
Negative 3/2. There we go. So that is the equation of my normal line. I'm looking for the point where that normal line meets the curve again. I already know that on this quadratic of x squared minus 3, the normal line meets at negative, or at 1, negative 2, but there's another point on the graph where it's meeting again. I'm trying to figure out what that point is. So again, I go into my calculator and I'm looking for where negative 1/2 x minus 3/2 is going to equal x squared minus 3. I'm looking for that intersection point, the full point. Everyone should be in their calculator figuring out where they intersect again. I was almost spot on my picture. So remember, I already know one of those intersection points. I know this one. This is what was in the problem, 1, negative 2. I'm looking for the one on the left. So that's second trace, option 5. My cursor is like almost halfway in between. I just want to make sure the cursor knows I'm looking for the one that's on the left, so I'll move it closer. Enter 3 times. Did you guys get negative 1.5, negative 0.75? And y'all know I hate decimals, so what's negative 1.5 as a fraction? Negative 3/2, and what's negative 0.75 as a fraction? Negative 3/4. So the point where the normal meets the curve again is at negative 3/2, negative 3/4.